Good morning. First and foremost, I'd like to introduce myself. I am Alex Duarte, the commercial leader of the product line bio-based for Latin America at Braskem. I am very thrilled to be here to start the first of 4 acceleration events that we are organizing within the context of WCEF. I'm going to be the organizer of the first seminar, the role of bioplastics in circular and carbon neutral circular economy. Later on, there will be another panel moderated by Fabiana Quiroga, accelerating bioplastics in circular economy. For those who are here in presence and who will be here tomorrow, please keep your badges in order to use them tomorrow. And this is a cable that can be used in your cell phones. So that's a gift for you. I'd like to thank the people who are here in person and people who are online. At the end of the sessions, we'll have the opportunity of reading a few questions and listening to questions from people who are here. So for people who are online, there is a chat on the screen you see, and via the chat you'll be able to ask your questions and we'll read them to the panel members at the end of the session. The idea is to talk about the benefits of bioplastics and the challenges we have in the production chain and everything that has to be overcome. Now, without further ado, I'd like to start by calling the members of the panel. Valéria, Michel, the Tetra Pak Sustainability Director in Brazil. Flavio Castellari, an expert in bioeconomics and sugarcane technology. And last but not least, Sônia Chapman, my neighbor and director of ACP Brazil. Recently, I have read a report reading that there is an estimated growth for biopolymers of around 18% year over year until 2029. Of course, biopolymers, when we look at bioplastics in the world and we look fossil fuel plastics, there's a huge volume gap. But this growth shows that there is an interest in the chain in capturing carbon with bioplastics, and at the same time we realize that there are brands and consumers that have questions about using bioplastics. So that's what we are going to talk about here. And at the same time, we brought a company that will be able to share their experience in the use of bioplastics. And we are going to connect everything, all the dots. So shifting away from fossil fuel bioplastics and using bioplastics to capture carbon. And I couldn't start differently without talking about carbon sequestering. That's used in the production of our raw materials, and that's a raw material that can be used in some bioplastics, such as ethanol. Ethanol can be used to produce bioplastics, hence the presence of Flavio. I'd like to launch, Flavio, 2 provocations, controversial provocations. First, is there room in Brazil to use more ethanol as a source of raw material or as a raw material for bioplastics? And secondly, talking about green polyethylenes or renewable polyethylenes by Braskem. Of course, we use ethanol in order to, as raw material to produce a biopolymer. But what about the competition between ethanol allocated to produce bioplastics and the competition with the food chain? Thank you. Thank you, Alex, for the questions. Well, he gave first the word to a man, and it should have been ladies first. But the question is excellent because the growing supply of ethanol is very easy for Brazil. It's very easy for Brazil to increase its production. And the world at large. In our case, the ethanol was a driver to develop the sugar industry in Brazil. Brazil started producing sugar cane in 1500s, and until 2000, it produced 300 million tons per harvest every year. And then came a new technology, ethanol as a fuel. You can choose whether you're going to fill up your tank with ethanol or gas or a blend of those. And we went up to from 320 to 650 million tons every year. So that was a very quick acceleration. In 8 years, we doubled the production of ethanol in the country, and all this new sugar cane was destined to ethanol. So we had a small production of ethanol because the market for ethanol as a fuel was not very large, and the world had just started to look at ethanol as raw material, and we doubled the production in 8 years. Now, shifting away from sugarcane, let's talk about corn. 7 years ago, corn didn't produce 1 liter of ethanol in Brazil, and now it might account for 20% of the production of ethanol in Brazil, 8 million liters of ethanol. So we are able to react very quickly if there is demand. That's not a problem. Another interesting point you touched is the issue of sustainability. Why maize or sugarcane ethanol made in Brazil bring about an 80% decarbonization? In some of our plants, we have negative carbon, over 100% decarbonization. You might have a plant that produces first generation, second generation ethanol, electric power from bagasse and biogas. It has a negative carbon footprint. So today we are able to deliver sustainable raw material, scalable, very quickly scalable if there is demand. So there is no problem. Brazil uses 1% of its land to produce sugarcane, virtually nothing, and 0.5% is used for ethanol. So we can also increase our surface, and we have been growing because of technology. Our sugarcane produces or yields much more per hectare than what we had a few years ago. We'll have an average of 100 hectares per 100 per hectare, 100 tons. So we have also improved maize-based ethanol. So there are no raw material bottlenecks to produce plastics. The competition between fuels and other uses for ethanol is easy to solve because if you look at it, all the other uses are nobler. You add more value. So to manufacture ethanol as a fuel, I think it's much better to use ethanol for SAF, for food, etc., or for bioplastics. So we look at biochemistry to have more nobler uses for ethanol. So I don't see any hitches in the competition. Thirdly, we have several plants producing premium ethanol, and this is the one you use to produce bioplastics. So I don't see any problems. We have 360 plants in at work, but it's easy to develop others. We are able to produce 11 mills every year, and for those who don't know, the technology is 100% Brazilian. It's Brazilian technology delivered by Brazilians. So when you think of the supply chain, having to import things, if there are problems in China or in the United States or Russia, we'll keep on producing without any hitches because it's produced 100% in Brazil with 100% Brazilian technology. So I'd like to ask you to introduce yourself. Well, we think that everybody knows whom you are. My name is Flavio Castellari. I have been the director of the largest bioenergy cluster in Brazil, APLA, a local alcohol productive hub, and I'm also the director of the technology hub in Sorocaba. I left both last year, but in the last 18, 19 years of my life, I lived for sugarcane. And one of the projects we had was the export of sugarcane Brazilian technology in order to promote diversification all over the world. In the last 18 years, I had 200 international missions promoting diversification and Brazilian technology. Two words were very important for the growth of sugarcane industry in Brazil: flexibility and diversification. So that's what I did, develop technology and to promote or disseminate the use of this technology both in Brazil and abroad. Now, since we have room to increase volumes, we have available raw material to increase the volume of bioplastics, and that won't necessarily interfere with the food chain. I'd like Sônia to introduce herself and talk about what we can do in order to compare bioplastics to other solutions. If you could explain what ACV means and how it can be used as a tool to compare raw materials and to be able to share the advantages brought about by bioplastics. Well, I'll try to be brief. First, thank you for the opportunity of being here. I am at home. I am the executive secretary of the ACV network that exists for 12 years. We have businesses as members, but also academia, associations, etc. And I'd like to talk about life cycle of products. Now, in our decisions, we started taking into account raw materials involved in the production of the given product, how they were extracted, what happens at each stage, and also at the product's end of life cycle. So we started wondering about that, and we felt more responsible for what happens in a more integrated manner. And this is what we call thinking about a life cycle.
So we think about improvements, how to reduce waste and reutilize materials, and also not transfer my problem to the next bond in the chain. So to avoid that problem shifting, transferring the problem to another bond in the chain, we must keep in mind this prospect of life cycle. So life cycle analysis is a method. We even have a standard for this calculation to show the difference between different raw materials, the water that was used, the land, the transformation needed for you to produce that. So that is a method of calculation, and you used a magic word, which is comparison. We can make a comparison of different packaging materials because they're both packaging. So Those of us who work looking at a life cycle analysis, the first question we ask is, what is that function? Is it packaging? Right. Is it packaging plus storage? Is it packaging plus piling up? Because then you need different requirements to that packaging. Life cycle analysis is therefore a method that allows for us to compare different things when they share the same function, the reason of being. So they all share a same function, which would be packaging in my example. When you conduct a life cycle analysis, or even yesterday when we had a workshop on life cycle analysis, when people begin to think about that, they see things they did not see in the past. Things become clear. So it's not that I'll recommend a life cycle analysis for everything we do, but we shall begin to think about the impact on the life cycle every time we're going to buy something in the supermarket or talk about products with a member of our family, because then we have more people thinking about this together. No doubt. In fact, as I was listening to you, I was thinking with myself, the time has come when narratives sometimes win over scientific data. So we have to understand how things work very clearly to make the right decisions. So, yes, now we have raw materials, then we have bioplastic production. We can make a comparison to different solutions, and then we come to the moment of using that. And it is a pleasure to be here with you. We worked together for 5 years, right? Yes, working in different agendas. So can you please introduce yourself and tell us about your experience in Tetra Pak in the use of bioplastics for your packaging solutions? In fact, today we even have bioplastic in our bottles of water. So as we look at the circular economy, then what is the impact of bioplastics? What was the impact of bioplastics for recycling, for example? Hello, good morning. Alex, thank you so much for inviting me. We've had this partnership for such a long time, visiting sugarcane plantations and plants. Let me begin by telling you how this initiative began. Today, I am a director of sustainability at Tetra Pak, and for us, sustainability is a strategy which permeates different initiatives. One of them is renewability. In fact, before this talk, I was having a conversation with Sônia, and we conducted our first life cycle analysis in 1969. Such a long time ago, because we wanted to understand each bond in our value chain. And our packaging is basically paper, 75% paper from renewable sources. So we already took that first step. But then we wanted to advance in our renewability strategy. So the second step was polyethylene that had a fossil origin. And then we began this conversation with Braskem. How can we migrate from a fossil polymer to a sugarcane polymer? And Braskem was developing this technology. So it was a match made in heaven. We began to develop that application, and today this polyethylene has a certification that it comes from renewable sources. But none of that existed at the time, and my first question to Braskem was, but what is the true benefit for us to migrate from a fossil polymer to a green polymer, sugarcane polymer? Shall we conduct a life cycle analysis? So that was the first thing we did, a life cycle analysis to make decisions based on data. We wanted to justify our decisions based on data. That's how Tetra Pak works. We want to have certification and traceability, and Braskem has always been a great partner because Braskem could see how relevant that project was. And so we were together. In 2007, we launched the sugarcane polyethylene for the caps of our packaging. And then in 2011, it was also included in the layers of the bottle to increase the renewable content of our packaging. Our commitment is to increase this content until 2030, and sugarcane polyethylene was a great second step. We began using paper, and now we are increasing the percentage of sugarcane polyethylene in our packaging. Of course, we faced challenges, but overall, it's been a great project. Of course, we are dealing with end consumers, and a few end consumers do not yet understand the difference between fossil fuel materials and renewable materials. So we have to foster this culture. Now, the other point about recycling, which you also mentioned, one of our concerns, I'm a chemical engineer, so to me it was much easier to understand these processes. But you have a number of people working at Tetra Pak locally and globally, and many of our customers, they would say, but what will change? Do we have to change our machinery? Will clients have to change their machinery? What is the impact for recycling? So this was a whole development project before we could launch the new packaging. We conducted tests, and the sugarcane polyethylene does not really change anything. And I learned this from you. It changes. How can you prove that this cap is made with sugarcane polyethylene and not fossil fuel polyethylene? Well, we conduct a carbon-14 analysis to know the age of the carbon on the cap or in the cap. So that's what we did. We conducted all these studies to be able to understand and then test. But after we had the polymer, then everything is the same. The recycling process is the same from the technical standpoint. What is the difference? Well, the profile of the material is better, but the mechanic properties, for example, remain the same. But we needed a number of years to show and justify all of this using data, using reports. First to justify that for Tetra Pak and then for the society. What's the true benefit of migrating from fossil polyethylene to sugarcane polyethylene? So we worked together in that process. As I listen to you, Valéria, we can see that the circular economy requires also recycling. If you use bioplastic, that is connected to the economy. You maintain all the same properties needed for recycling, and at the same time you're using materials that are capable to capture carbon and therefore reduce your carbon footprint. But so this is possible. We have the raw materials. We can compare different raw materials. We have your business case, which is a success, and many other success cases. Today here at Cazoolo, we are conducting this meeting in Cazoolo, and that is our design lab for sustainable packaging. That's Braskem Design Lab. And we also have other applications of biopolymers from renewable sources, not only packaging. But what about the future? What are the challenges from now on? And I think this is an important point. What is the market view? What's the market perception of bioplastics? So Val, maybe you can begin to talk about this. What is the perception of customers? On the demand side, are customers also increasingly more interested in bioplastics as we are? And to what extent are bioplastic importance to reduce Tetra Pak carbon footprint? So let me begin from the end, from the decarbonization process. The use of materials made from renewable sources is in line with our decarbonization strategy. Tetra Pak has a net zero commitment until 2030 for all the operations, and in our value chain, we have time until 2050. So that is our commitment, which is pretty aggressive because in the value chain, we're talking about all our customers, all our suppliers. So there are many involved. And in terms of different solutions, in our decarbonization strategy, we include the use of raw materials made from renewable sources. And we have been talking about this also with customers. And we started this process back in 2007. Why? Because that's really important for the sustainability. You need to exchange information and then migrate to renewable source materials. But everything begins from the consumer. The consumer has the power to say, I want materials made from renewable sources. I want to use recyclable packaging. This is a decision that only consumers can make. And now thinking about Brazilian consumers compared to consumers elsewhere, in Brazil, consumers do not yet understand it clearly. We conduct a number of surveys with end consumers about their priorities in terms of sustainability. And today, the number one priority for them is recycling, because this is a true pain point in Brazil. Selective collection of waste and recycling. So in all surveys we conduct, the number one priority is always recycling. What about renewable? We try to ask questions in the surveys about renewable to see whether people understand what renewable means. And unfortunately, end consumers do not understand. They talk about biodegradable. They mix up different concepts. So I think we still have to make a lot of progress in providing information to people. I know this is a technical subject, but sometimes you have to provide easier information that people can easily understand. But I'm talking about all types of consumers. It doesn't matter what social bracket they come from. We have to provide easy information for consumers to understand and therefore choose products that come from renewable sources. In Europe, it is different. In fact, biopolymers are mostly consumed in Europe. Why? Because of the consumer level of awareness. It's very different from Brazil. In Europe, you see a growing demand for sustainable products. In fact, the volume we buy from Braskem is sent to Europe as a priority. Why? Because of the demand in the consumer market in Europe. But we have the Tetra Pak index in our company looking at consumption trends in food and beverage. And in the last edition of this survey, we could see that 55% of the people interviewed were concerned about, they want to consume healthier products. That's first. And 70% of those interviewed said healthier and sustainable. So I want to buy food that is healthy and also sustainable. So the packaging has to be recyclable. The raw material must come from renewable sources. And this is a clear trend which shows a positive curve of evolution here. We're not yet where we want to be with a higher demand, but we are on the right track, and education can truly make a difference. Thank you. As we look at the future, there is a challenge to explain to all bonds in the chain how this magic happens. But if we have a demand, there will be an interest in doing it. And now, Sônia, I'd like to ask you about the future. Do you see a change in the regulations? Do you see discussions about that? And also, I'd like to ask you to perhaps make a comparison between different materials and make that information available so people can make informed decisions. Do you see we have a barrier in terms of the acceptance of bioplastics in the future? The future, let me get my crystal ball. Yes, in our network, we talk about different levers looking at the life cycle analysis because you need neutral scientific studies to support information. Of course, we also have public policies, sustainable aviation fuel, SAF, also the Brazilian policy of solid waste, which talks about shared responsibility throughout the life cycle. Now the new circular economy policy and the new circular economy plan. And then now we're having this forum, the Circular Economy Forum, happening in Brazil for the first time. And that's great, because not only do we make a bridge between those who face the problem and those who can provide a solution, but also we can see that our challenges are giant domestically, but they are also present internationally. And it's urgent for us to do something. The problem is that sometimes you have to change things that looked successful so far. One of the ways to make change is to establish public policies, because then everybody will have to begin to do such and such things. Otherwise, there will be a penalty, a fine. But then we have a few other levers, for example, certification stamps, for example, the sucre certification, and then you begin to see requirements to have a certain certification. In agriculture, for example, all the decisions used to be on the farm, but now decisions are made outside. Today we speak about scope 3, and many times because we have to improve our management, and that is a challenge. Sometimes we have to invest in new technology, but sometimes that's not just an internal decision. That's also a decision made outside. And then you have scope 2, which includes the consumption of power, and then scope 3, which involves so many bonds in the value chain that many times we don't even know that. So most initiatives will go as far as scope 1 and scope 2. Having a commitment to scope 3 is beautiful. It's something admirable, because then you will begin to think about other levers that go beyond public policies. It will require quality data, because it is of no use to run a study based on data which is not of top quality, which does not really reflect the Brazilian reality. So thinking about Embrapa, Agricultural Research Institute in Brazil, they provide top quality data for us to understand the current situation, the current circumstances of production in Brazil. So data is a requirement in this transition because we need comparability. We also spoke about education. We must provide technical training, but also general information so that people can begin to make better decisions by themselves. So we have a number of things to do, but a few levers are speeding up some of these initiatives. We now have the Global Pact to reduce the consumption of plastic, ISO 14001, which, you have certification, but then you have recertification, so requiring higher commitments to the life cycle. And that's not only about suppliers. That also includes consumers. Who are you selling your product to? Are you selling to anyone? What's your customer going to do with your product? So all of that, and also the disasters that we see worldwide, humanity, mankind in general now understand how much we are intertwined, how much we are interconnected. Not only supply chains, in the pandemic, we could see that our supply chains are more fragile than we thought. So today I feel even more optimistic. I believe that these meetings that we are holding this week, when we have so many people, I mean, we did not even have any more places for more participants. So I can see that Brazil wants to be part of the solution. Brazilian people want to be part of the solution. So, of course, we have public policies, we need design, we have the disasters that also help people understand. But basically, we have people willing to make a difference, people willing to be part of the solution. And that is just great. While I was listening to you, I remember a case in Japan. Japan has recommendations. So they recommend that for some applications, the companies should use a certain content of bioplastics. And for them, recommendations make a lot of sense. And AI, artificial intelligence, is going to be very helpful because it will help us have access to data and compare different circumstances in Brazil and Europe. China is building a giant database using AI where we still have blind spots, where we still don't have information. They're now using AI to fill in those gaps. So they expect to have higher quality data. Yes, and I also agree it is urgent. We participated in the forum meetings for 2 days, and we could see there is this feeling of urgency. We should have started earlier, but it's urgent now. We are coming to the end of the panel, so let me go back to Flavio, to the beginning of our production chain. Flavio, I hope we continue to be friends because I'm also going to launch another provocation. But I saw a video of yours from Dubai, from the COP meeting, and I think we have already talked about that. And this is the responsible production of ethanol in Brazil. What can you tell us about that? I know there are a few tools, and I also know the process, but I would like you to explain it to us. And the second question, can we use the Brazilian expertise in the manufacturing of ethanol and export that know-how to other countries in the world so that it can also be a raw material for bioplastics elsewhere? No, I will still be your friend because your questions are actually not so difficult to answer. But today we're talking about life cycle, and we have to continue to talk about life cycle because people have to understand that a plug-in electric vehicle, you have to understand where the energy comes from and how that car will be disposed of. So we have to think about the end-to-end life cycle. And I used many studies from Tetra Pak to talk about this. Renewable is easy to explain. Oil. Oil is the raw material of fossil plasticos. So you drill a well and then you remove oil from underground for many years. Ethanol is different. You have to plant, then you have to take care of the plant, then you have to harvest, and then use that raw material to make the product. So ethanol has a soul. Why? Because it had human labor during the manufacturing process. And it's renewable because every year you have to plant and harvest and process your product. So back to Alex's question, for something to be renewable forever, you have to be sustainable. Otherwise, it's not going to be forever. If you just extract from nature, one day Mother Nature will complain because you have to replenish. You have to take care of nature. For us, the plantation fields are something I have to take care of. Otherwise, I will not have good land to plant tomorrow. And we have to be sustainable because sugarcane processing is different from other raw materials. Other raw materials you can import, not sugarcane. Your mill has to be very close to your plantation. If it is further away, more than 50 kilometers, you cannot produce your ethanol. So you have to buy your raw material locally. You cannot buy it from the other side of the world. So sustainability is key, not only environmental sustainability, but also social sustainability. Social sustainability because a sugarcane mill provides employment away from urban centers, away from urban areas. So as you think about sustainability, if you look at a sugarcane mill, 80 years ago, all sugarcane mills were by a river because you needed water from the river for the industrial process. Today, a sugarcane mill can be located anywhere because our industrial production cycle is a closed loop. We reutilize all the processed water we use. So it's a closed loop. That's why we say this is a sustainable raw material. Our sugarcane mills are sustainable. All our equipment has filters so that we can treat processed water, and we don't lose anything. In the sugarcane mill, we use the waste. Something that can be waste for someone else is a raw material for us. Even the ashes from the process, we will use them again. Or the sludge that is left at the end of the process will be used as a fertilizer in the plantations. So this is a closed loop economy. Just look at a sugarcane mill and you will understand what we mean by circular economy. We use our own energy. We produce our own energy, and it's clean energy because it comes from our own waste. We burn our waste, then we treat the smoke. So our industry is fully sustainable, and we have no choice. We have to harvest and process in 24 hours because that is how we work. And now we want to be even more sustainable. We want to replace all the diesel we use for biogas. It's not even natural gas, it's biogas, which has a negative carbon footprint. And we will use that as fuel for our trucks and tractors. So when I deliver ethanol to a gas station, I will be using a vehicle run on that kind of power.
And as to scaling, I don't have much time, so I'm going to be brief. There are 100 countries producing sugarcane industrially, harvesting, processing, and manufacturing sugar or producing sugar. All of them can produce ethanol and produce electric power from bagasse. So we have been spreading all over the world a Saudi Arabia of renewable energy. It's a lot of energy. People producing oil that cannot plant sugarcane say, wait a minute, what about the geopolitical balance or balance in the world? Energy. So whenever oil goes up, everything goes up. When it goes down, some things go down. So people dominating the economy in the world is energy producers. So if you transfer that to the southern hemisphere, we're going to produce food and energy, and hence a question, a tricky question, which is food versus fuel. Today it's food plus fuel. You have to produce food and fuel, prioritizing food, of course, as FAO says. But imagine the southern hemisphere producing all the food the world needs and the energy the world needs and renewable energy. So we have a gigantic potential. It's easy to roll it out, and many countries blend ethanol in gas. So we have ethanol in approximately 50 countries. Very good. Thank you all very much. I think we can open the floor for questions. I didn't get any questions from people online. I don't know if you have any questions here to the members of the panel.
Yeah, I would like to ask a question in English, if that's okay.
That's okay. Yeah.
My name is Ebenezer. I'm a professor from Aston University in the UK. And I'm also the project director of a project where we're working to develop A lot has been said about consumers by the panel, and also obviously consumer attitudes to bioplastics, as well as the biodegradability of bioplastics and the life cycle analysis as well. One of the shifts that's happening in the global conversation is around the compostability of bioplastics, and how that contributes to a positive end-of-life use. So if you think of sort of the circular economy where the bioplastic can become composted, and then for that compost to go back into the soil, to help grow whatever vegetation that we're using to create the bioplastics. And my question is, what is the approach to compostability at the moment when it comes to bioplastics here in Brazil? And what are the consumer perceptions around that? Because obviously in Europe, as one of the panelists said, it's slightly different. Consumers are expecting more and more for bioplastics and other plastic alternatives to be compostable. I just want to understand what the approach is here in Brazil. Thank you very much.
In English? No. Na rede ACV nós temos.
At ACV, we have a work task of circular economy and another one about labeling. And in the labeling group, whenever we look at a statement about certifications, etc., we keep that in an image bank. And a while ago, I was in a place where the packaging stated, plastic packaging said that it was plant-based packaging. So I got very intrigued, and I went to their site to see if there was a customer service so that they could clarify what plastic was, etc. And then it took eternity for someone to answer, and I finally, after several denials, because that was not provided for in the automatic script of answers, finally they put me in touch with the person that explained what kind of plastic was, because they said it was plant-based plastic because of the raw material, but also because of its compostability. But there is no point in being compostable theoretically if consumers are not informed of what they have to do, where they should take the material, where it should be taken. So in order to be composted, I don't know about Europe, but here we lack customer service that would clarify consumers' questions, difficult customers as I am, who want to be part of the solution. Where should I take that in order to be compostable? And there was no such information. And this is something we should have said if we had time. It was the greenwashing, right? We induce consumers to pick one product over the other because of this appeal, but we don't give the customer the final solution, so to speak, so that those claims can become true. So even if in theory it is compostable, if I don't take it to the right place, it won't be selected, it won't be sorted appropriately, and we'll have the same destination as other kinds of plastics. But let's suppose everything works smoothly and it gets to the rural grower and it will be exposed to the rain and to the weather in order to be decomposed. It could be that a given component might harm the soil and stays there. So we have to be very careful with this kind of statement when there is no structure that states that proves that the desired decomposition is happening. Well, in the same lines, along the same lines as Sônia, I'd like to say that renewable doesn't mean necessarily biodegradable. Some plastics might have that characteristic, but it might be confusing for consumers. And in Brazil, there are no chains for recycling, let alone for biodegradable products. And as Sônia said, there are biodegradable products that have specific conditions or characteristics, and that requires a given level of information. So it won't be degraded if it doesn't get to the right place. So it's a lot of technical concepts for customers sometimes. So it can be a very interesting alternative, but the local reality of each country has to be adapted to it. Otherwise, you will have an excellent solution that will end up in the dump because it wasn't properly recycled. It might interfere with other products recycling. So in Brazil, I can say that we have no such structure for that. Thank you. There's another question online. What's the growth prospects for biopolymers in the next few years in Brazil, in the world, and which segments should spearhead this growth? Yeah, the study I mentioned in the beginning of the panel saying that the increasing use of biopolymers in the world should get to 18% by 2029. In Brazil, there is increased supply from 200,000 to 275,000. This increased capacity happened in late 2023. There is another company also interested in producing bioplastics in Brazil, and that will add another 3,000 tons. And when you look at the world at large, I think there will be an increase in bioplastics spread all over the world, especially thanks to the new legislation, a huge increase in China and India, because there is an interest in biodegradable polymers or compostable polymers, and there is a biopolymer that can be used for that. So there is a huge possibility of growth in those countries. And we look at the segments that should spearhead that. In my opinion, most probably those applications having a shorter life cycle will be the segments spearheading this growth. But at the same time, and now talking about South America, which I'm more familiar with, here we have the decarbonization initiative in the automakers. Several projects are being worked on in order to use bioplastics in the automakers, cars, trucks, motorbikes, etc. The cosmetic industries, foodstuffs. There are several segments interested in using biopolymers in South America. With that, we are about to wrap up. I'd like to thank you on behalf of Braskem, Sônia, Valéria, and Flavio for being here. And I'd like to wrap up this session. Thank you very much for your attention.
Pessoal, só uma orientação rápida.
A quick announcement. Let's break. Coffee, water, snacks are served to the left of the room, and we resume at 10:30.